So today let's discuss questions related to indeterminate forms. So there were around 9 to 10 questions asked on this topic. So let's see them one by one. So the question 1 says that find the limit of this when x approaches 0. So we are supposed to find limit x approaches 0 of function cot x minus tan x raised 1 upon log x and its base is e. So if I just put value of x here, so I'll be getting cot 0 upon cos 0 cot 0 minus tan 0 raised 1 upon log e0. Log 0 is basically minus infinity and cot 0 is infinity and 1 upon infinity is 0. So it is infinity upon infinity raised 0 form. So let us see how we can solve this question. So what we can do is we can take a log of this whole term. So let us assume that this limit is equals to L. So if we take log of this whole term, let's name it as 1. So we'll be getting log L is equals to log of limit x approaches 0 cot x minus tan x raised 1 upon log ex, which is basically equals to log L equals to limit x approaches 0 log of cot x minus tan x raised 1 upon log ex. I am able to do so because log of limit x approaches a x is equals to limit x approaches a log x. So because of this I am able to take this limit outside of log. So from here I got log L is equals to limit x approaches 0 log cot x minus tan x divided by log x, because log of x raised a is equals to a log x. So if I put limit here, so I'll be getting log of cot 0 log infinity, that is infinity, upon log 0, that is also infinity. So I'm getting infinity upon infinity form again. So if I apply L'Hopital rule on right hand side, so I'll be getting limit x approaches 0. Derivative of log x is 1 upon x. So from there I'll be getting cot x minus tan x into derivative of cot x minus tan x divided by derivative of log x, that is 1 by x, into derivative of x, that would be 1 only. So my limit is basically equals to limit x approaches 0 x into d by dx cot x minus tan x divided by cot x minus tan x. Now I can take derivative of this term and then simplify it further. So I'll be getting limit x approaches 0 x into derivative of cot x is minus cosec square x and derivative of tan x is sec square x divided by cot x minus tan x. I can take minus outside, so this limit will be basically equals to limit x approaches 0 minus x into cosec square x plus sec square x divided by cot x minus tan x. This will be basically equals to limit x approaches 0 minus x into I'm just converting this cosec and sec x in sine and cos form to just simplify it a bit. So I'll be getting 1 cos x is 1 upon sine x and square plus sec x is 1 upon cos x square divided by cos x by tan x sin x minus sin x by cos x. So if I simplify it, I'll be getting limit x approaches 0 minus x into sin square x plus cos square x divided by sin square x into cos square x divided by cos square x minus sin square x divided by sin x cos x. So this sin x balances 1 power here, and likewise this cos x balances 1 power here. So my limit is basically limit x approaches 0 minus x into sin square plus cos square x is 1. So into 1 divided by cos square x minus sin square x is basically cos 2x into sin x cos x. So what I can do here is I can multiply and divide by 2 so that I can form sin 2x here. So this will be basically equals to limit x approaches 0 minus 2x divided by 2 into cos 2x into 2 sin x cos x, that is basically sin 2x. Now I can further multiply and divide by 2 so that I'll be getting limit x approaches 0 minus 1 into 4x upon sin 4x, because sin 2x is 2 sin x cos x, so sin 4x is sin 2x cos 2x. This is basically equals to limit x approaches 0 minus 1 into 1 upon limit x approaches 0 sin 4x upon 4x. This is basically equals to minus 1 upon 1, which is minus 1. So from here I got L as e raised minus 1 as limit. So let's see next question. So the next question asks us to evaluate this limit. So we're supposed to find limit x approaching infinity e raised x plus x raised 1 by x. So if I put x raised infinity here, so I'll be getting infinity raised 0 form. So first let us just equate it with L to get rid of this 1 by x exponential part. So for that let's take log on both sides. So I'll be getting log L is equals to limit x approaches infinity log e raised x plus x raised 1 by x. This thing will be equals to limit x approaches infinity log e raised x plus x divided by x. So if I put limit here, I got infinity upon infinity form. This is also still it's in indeterminate form. So let us just use L'Hopital rule to solve it further. So I'll be getting 1 upon e raised x plus x into derivative of e raised x plus x, that is basically equals to limit x approaches infinity e raised x plus 1 upon e raised x plus x. Now if I check, then again it's in infinity upon infinity form. So again I need to use L'Hopital rule, that basically gives me e raised x upon e raised x plus 1. It's still in infinity form, so again using L'Hopital rule I'll be getting e raised x upon e raised x. Now this time this e raised x balances the 1 in numerator, so I got limit x approaches infinity 1, which is equals to 1. So I got my log L is equals to 1, but my limit, I have assumed that limit is equals to L. So from here my L is basically e raised 1. So my L is e. Let's move on to next question. So the next question asks us to evaluate this limit. So we are supposed to find limit x approaches 0 1 upon x square minus cot square x. So this is infinity minus infinity form. If I put here 0, so it will be infinity, and cot 0 is also infinity. So let's solve it. Let's first simplify it a little bit. So I'll be getting 1 upon x square minus cos square x upon sin square x. This will be equals to limit, so x approaches 0 sin square x minus x square cos square x divided by x square sine square x. So if I check by substituting limit here, I'll be getting 0 upon 0 form, which is again a indeterminate form. So let's use L'Hopital rule here. So if I do so, I'll be getting 2 sine x cos x minus 2x cos square x minus x square into 2 cos x minus sin x. By that this will become plus. So, and in numerator it will be 2x sine square x plus x square into 2 sin x cos x. Limit x approaches 0. Sin 2 sin x cos x is basically sin 2x minus 2x cos square x plus x square into, again this 2 sin x cos x is sin 2x divided by 2x sin square x plus x square into sin 2x. So if I simplify it, I can write it as limit x approaches 0. I can take sin 2x common from this and this term. So I'll be getting sin 2x into 1 plus x square minus 2x cos square x divided by 2x sin square x plus x square into sin 2x. Now if I just substitute limit x equals to 0 herein, again I'll be getting 0 upon 0 form, which is again an indeterminate form. So let us use L'Hopital rule again. So if I do so, I'll be getting limit x approaches 0. Sin 2x will be cos 2x into 2 into 1 plus x square plus sin 2x into 2x minus 2 cos square x minus 2x into derivative of cos square x will be 2 cos x minus sin x divided by 2 sin square x plus 2x into derivative of sin square x will be 2 sin x cos x plus x square into cos 2x into 2 plus 2x into sin 2x. This will be equals to limit x approaches 0 into 2 into 1 plus x square into cos 2x plus sin 2x. Here also it will form sin 2x. So I'll be getting 2x plus 2x 4x sin 2x minus 2 cos square x divided by, here it will form sin 2x and this sin 2x again, 2 sin square x plus 4x sin 2x plus 2x square cos 2x. So if I put limit x equals to 0 here, so I'll be getting, it will be 2 plus 0 minus 2 divided by 0 plus 0 plus 0. So again it is 0 upon 0 form. We are supposed to apply L'Hopital rule again. So if I again use L'Hopital rule, I'll be getting limit x approaches 0 into 2 to the 4x cos 2x plus 2 into 1 plus x square. Derivative of cos 2x is sin 2x minus sin 2x and derivative of 2x is 2. So minus 2 sin 2x plus 4 sin 2x plus 4x. Derivative of sin 2x is cos 2x and derivative of 2x is 2. So it will be 8x cos 2x minus 2 to 2 cos x into minus sin x divided by, if I take derivative of denominator term, I'll be getting 4 sin x into derivative of sin x will be cos x plus 4 sin 2x plus 4x cos 2x into 2, so it will be 8x 2x. So derivative of this will be 2 2s are 4x cos 2x plus 2x square minus 2 sin 2x. So if I simplify it, I'll be getting limit x approaches 0, 4x cos 2x plus 8x cos 2x, it will be 12x cos 2x plus 4 plus 2, 6 sin 2x minus 4 into 1 plus x square sin 2x divided by 2 into sin 2x plus 4, so it will be 6 sin 2x plus 8x plus 4x will be 12x cos 2x minus 2 to the 4x square sin 2x. If I check limit of this term, again I'll be getting the same thing. So let's just see what we get. If I put x equals to 0, so it is 0 in numerator and in denominator 0 0 0. Again it's 0 upon 0 form. So let's use L'Hopital rule again. So if we do so, we'll be getting limit x approaches 0, 12 cos 2x minus 12x sin 2x into 2, so it will be minus 24x sin 2x plus 6 to the 12 cos 2x minus 8x sin 2x minus 4 into 1 plus x square, and derivative of sin 2x will be cos 2x into 2, so here it will become 8 divided by 6 into cos 2x into 2, so it will be 12 cos 2x plus 12 cos 2x minus 12x sin 2x into 2, so it will be minus 24x sin 2x minus 4 to the 8x sin 2x minus 4x square. Derivative of sin 2x will be cos 2x into 2, so it will be minus 8x square cos 2x. So I can simplify it. It will be equals to limit x approaches 0, cos 2x plus cos 2x, so it is 24 cos 2x minus 24 minus 8 minus 32x sin 2x minus 8 into 1 plus x square cos 2x divided by 12 plus 12, again 24 cos 2x minus 32x sin 2x minus 8x square cos 2x. So if I put limit x equals to 0 here, so I'll be getting 24 minus 0 minus 8 into 1 plus 0 into 1 divided by 24 minus 0 minus 0. So my limit is basically 24 minus 8 divided by 24. It is 16 by 24, that is 2 by 3. So the limit of this term is basically 2 by 3. Let's see next question now. So in next question we are supposed to find out this limit. So that is limit x approaches pi by 4, 10x raised 10 2x. So if I put value of x as pi by 4, I'll be getting 1 raised 10 infinity 10 pi by 2, that is infinity. That is indeterminate form. So to simplify it, let's equate it with L and take logarithm to get rid of this exponential term. So we'll be getting log L equals to limit x approaches pi by 4 log 10x raised 10 2x. So this thing will be equals to limit x approaches pi by 4 log 10x into 10 2x. So this thing will be equals to limit x approaches pi by 4 log 10x divided by cot 2x. So again, if I put x equals to pi by 4, I'll be getting log 1 as 0 divided by quote pi by 2, that is again 0. So I got 0 upon 0 form, which is an indeterminate form. So let's just simplify this equation. So I'll be getting a limit x approaches pi by 4. So if I apply L'Hopital rule here, so I'll be getting 1 upon 10x into derivative of tan x upon derivative of cot square x, so that is minus cosec square 2x into derivative of 2x, that is 2. This will be equals to limit x approaches pi by 4, 1 upon tan x into derivative of tan x is sec square x divided by minus 2 into cosec square 2x. So let's just convert it in sine and cos form to simplify it a bit. So we'll be getting minus 1 by 2 into limit x approaches pi by 4 cos x upon sin x into 1 upon cos square x upon 1 upon sin 2x whole square. So this thing will be basically equals to this cos x balances this one. So if I take this 2 inside, so I'll be getting minus 1 into limit x approaches pi by 4 1 upon sin 2x into this sin 2x whole square will get in numerator, so it will be sin 2x whole square. This sin 2x balances this one, so I am left with limit minus 1 into limit x approaches pi by 4 sin 2x, so that is equals to minus 1. So from here I got my log L as minus 1. So my L, that is the limit, is e raised minus 1. So let's move on to next question. So the next question asks us to evaluate this limit, that is limit x approaching 1 x raised minus 1 into 10 pi x by 2. So if I put limit x equals to pi by x as 1 here, so I'll be getting 1 minus 1, that is 0, into tan pi by 2, that is infinity. So it is a 0 into infinity indeterminate form. So this limit is basically equals to limit x approaches 1. I can write it as x minus 1 divided by cot pi x by 2. Now if I check this, this will be basically 0 upon 0 form. So I can use L'Hopital rule here. So if I use L'Hopital rule, it will be 1 upon 10 pi x by 2. Sorry, derivative of tan x is minus cosec square. So it will be minus cosec square pi x by 2 into pi by 2, which is basically equals to limit x approaches 1 into 2 by pi into minus 2 by pi into 1 upon cosec is sine, so it will be sine pi x by 2 square. So if I take limit, so I will be getting minus 2 upon pi as the limit of this term that they have asked, into 1. Sine pi by 2 is basically 1, so and square of that is also 1, so my limit is minus 2 by pi. So let us see next question. So the next question asks us determine if this limit 1 minus x tan pi z by 2 exists or not, and if it exists then find its value. It's the same question I guess that we did right now. Yeah, it's just here it is x minus 1 and here it is 1 minus x. So this limit will be basically equals to limit z minus z approaches 1 will be 1 minus z into 10 pi z by 2. This will be equals to limit z approaches 1 minus, I can take minus 1 outside, so it will be minus 1 into z minus 1 10 pi z by 2, and this limit we have found out In previous question it is minus 2 by pi, so it is minus 1 into minus 2 by pi, so this will be equals to 2 by pi. Let's see next question. So the next question is evaluate the following limit. So we're supposed to find this limit where x approaches a and the function is 2 minus x by a into 10 pi x upon 2a. So if I just put limit x approaches a, so I'll be getting 1 raised infinity, which is an indeterminate form. So let's just take log to get rid of this exponential thing. So I'll be getting, let's equate it with L, and if we take log, I'll be getting log L equals to limit x approaches a log 2 minus x by a raised 10 pi x by 2a. This thing will be equals to limit x approaches a, this term will come out in of exponential, so it will be pi x by 2a into log 2 minus x by a, and I can write tan as 1 upon cot, so I'll be getting limit x approaches a log 2 minus x by a upon cot pi x upon 2a. So if I put limit here, so it will be 0 upon 0 form. So let's use L'Hopital rule here. So if I use L'Hopital rule, I'll be getting limit x approaches a 1 upon 2 minus x by a into minus 1 upon a divided by derivative of cot will be minus cosec square pi x upon 2a into pi upon 2a, which is basically equals to this a balances out this one and minus balances out this minus. So I am getting limit x approaches a 2 by pi into 1 upon 2 minus x by a into sine square pi x upon 2a. So if I put x equals to a, I'll be getting 2 by pi into 1 upon 2 minus 1 into sine pi by 2, that is 1. So my limit is basically 2 by pi, but this 2 by pi is equals to log L, so my limit is L, so L is basically e raised 2 by pi. So this is the required limit that we are supposed to find. So in this question we are supposed to find this limit. So this will be limit x approaches 0 2 plus cos x upon x cube sin x minus 3 upon x raised 4. So let's just take LCM to simplify it a bit. So we'll be getting 2x plus x cos x minus 3 sin x divided by x raised 4 sin x. So we can write it as limit x approaches 0 2x plus x cos x minus 3 sin x divided by x raised 5 into x divided by sin x, and this limit will be approaching 1. So we'll be getting limit x approaches 0 2x plus x cos x minus 3 sin x upon x raised 5. So let's just simplify this. If I put limit x equals to 0 here, so I'll be getting 0 upon 0 form. So let's use L'Hopital rule here. So I'll be getting limit x approaches 0 2 plus cos x plus minus x sin x minus 3 derivative of sin x will be cos x divided by 5x raised 4. So this thing will be equals to limit x approaches 0 2 minus 2 cos x minus x sin x divided by 5x raised 4. So if I put limit x equals to 0, again I'll be getting 0 upon 0 form. So let's simplify it further. It's 0 upon 0 form, so we can use L'Hopital rule again. So I'll be getting minus 2 sin x minus x cos x divided by 5 4 20 x cube. So this thing will be equals to limit x approaches 0 sin x minus x cos x divided by 20x cube. So if I put limit here, I'll be getting 0 upon 0 form again, and this will be equals to limit x approaches 0. Derivative of sin x is cos x minus cos x plus x sin x divided by 60x square. This cos x balances this one, so my limit reduces to limit x approaches 0 x sin x upon 60x square. This will be equals to limit x approaches 0 1 upon 60 into sin x upon x. So this limit will be equals to 1 upon 60 because this tends to 1 as x approaches 0. So we are getting our limit as 1 by 60. So let's move on to next question. So in next question we are supposed to find out this limit. So that is limit x approaches 0 e raise ax minus e raise bx plus tan x divided by x. So if I put x equals to 0, it will be 1 minus 1 plus tan 0, that is 0, divided by 0. So this is basically 0 upon 0 form. So let's use L'Hopital rule here. So I'll be getting limit x approaches 0 a e raise ax minus b e raise bx plus derivative of tan x will be basically sec square x divided by derivative of x, that is 1. So my limit is basically limit x approaches 0 a e raise ax minus b e raise bx plus sec square x. So if I put x equals to 0, I'll be getting a minus b plus sec 0, that is 1. So my limit of this function is basically a minus b plus 1. So let's move on to next question. So in next question we are supposed to find out the limit x approaches 1 ln 1 minus x upon this cortex. I can write it as tan pi x by 2. So if I put x equals to 1, it will be ln 0 divided by tan pi by 2, that is infinity upon infinity form. So I can use L'Hopital rule here. That gives me limit x approaches 1 minus x into minus 1 divided by derivative of tan x is sec square pi x by 2 into pi by 2. So this basically, yeah, so if I simplify it, I'll be getting ln limit x approaches 1 upon x minus 1 into cos square pi x by 2 into 2 by pi. So this thing will be equals to 2 by pi into limit x approaches 1 cos square pi x by 2 divided by x minus 1. So if I take limit again, I'll be getting 2 by pi into limit x approaches 1 2 cos pi x by 2 into minus sin pi x by 2 into pi by 2 divided by 1. This pi by 2 balances this 2 by pi. So my limit is basically minus 1 into limit x approaches 1 2 cos pi by 2 into sin pi by 2, that is basically equals to 0. So I got my limit of this thing as 0. So yeah, these are the only questions that's asked for indeterminate form. So thank you for watching.